Hi, in this lecture we're going to cover more examples related to influence lines built with intermediate hinges. And in this lecture I'm going to talk about or cover two examples. Both of them have two intermediate hinges. This is the first one. We have the beam fixed at one part, has two intermediate hinges, and has two roller supports very close to each other. And we want to draw the influence line diagrams for the reactions, which are three reactions. Qn at section N, Mn, Qm at section M, Mn, Qk and Mk, and these are the locations of N, M, and K. N is on the left one, M is in the middle between the two hinges, and K is between the two roller supports. Okay, distances 3 meter to N, 2 meter to the intermediate hinge, 2.5 meter to N, 2.5 meter to N, so the distance between the hinges is 5 meters, 1.5 meter to K or to point B, support B, 2 meter to support C, and 1.5 meter to the cantilever. So at the intermediate hinge, we isolate this one, we make it a beam, and then support it on this one on the left side and support it on the one on the right side. So this one, it doesn't have any, it just has hinges. So we converted the hinges to two hinged supports. And then after we solve it, we reflect the reaction of this one and on the fixed beam, B cantilever one that has fixed E and free end after we finish. So three beams. The supported one is the top one, the supported ones are the two lower ones. The fixed D is at A, so we have YA and MA. And this is an example I didn't ask to draw the moment influence line for moment diagram. So it's your homework assignment to do the influence line for the moment diagram, and I've shown you how to do this in the previous example. So I will draw the influence line for YA at the support, fixed support, and YB at the intermediate roller, and YC at the end roller, the right end. And then influence line of shear and N, shear and moment at N, M, and K. Okay, influence line of YA. YA equals 1 when the load is on A, 1 when the load is on the free end of the cantilever. So it moves on the cantilever first. And then when it moves to the other hinge, it is 0. And then 0 beyond. So this is the influence line of the YA, influence line of YA, which is the support, vertical support action at the fixed support. 0 plus 1 constant, and then to 0 to ends at the intermediate hinge, and then to 0 at the other intermediate hinge, and 0 beyond. Influence line of YB, YB equal 1, YB equals 1 when the load is at B. From similarity of triangles, when the load is at intermediate hinge, it's 1.75, and then minus 0.75 to the cantilever, and then from 1.75 to the end of the two-hinged beam, the top one, the supported one to 0, and then 0 beyond. So this is the influence line of YB, influence line of YB. From 0 to 1.75, going through 1 at the support, to 1.75 at the intermediate hinge, to 0 at the other intermediate hinge, and 0 beyond. Influence line of YC. YC equals 1 when the load is standing on C, which is 1 at C, 0 at B, and then from 1 at C, one straight line extended to the cantilever, so it becomes 1.75. Extend this 1.7510 to the intermediate hinge. The curve becomes minus 0.75 to 0 at the other intermediate hinge, and 0 beyond. So this is the influence line of YC. See? 1.75, 1, minus 0.75, and 0 at the intermediate hinge, and 0 beyond for the rest of the beam. Okay, what about N? N is one close to the fixity. It's 3 meter right of the fixity. So what is the influence line of shear moment for N? For Qn, when the load is left of n, Qn equals 0, and moment Mn equals 0. And it is 1 until the end of the cantilever, which is this one, this cantilever. So it is 1 from n right to the end of the cantilever, and then 0 at the intermediate hinge, and 0 beyond. So 1, 1, 0, and then 0 beyond. Influence line of Mn at n equals 0. At the support, it is -2, and then 0 to the middle between the two hinges, and 0 beyond. So this is the influence line of Mn. If you want to calculate, like move the load and calculate the action. Move the load, calculate the moment. Move the load, calculate the moment, and confirm your values against the ones over here. Okay. So this is the influence line of Qn and Mn. Qn is this one, and Mn is the lower one. Influence line of Qm and mm. M is the middle point between the two intermediate hinges. Okay, so it's 2.5 meters each side. The intermediate hinges are 5 meters apart, and M is in the middle. So the supported one is the one that has M, and the unsupported one, and the supported ones are the lower ones, the cantilever and the other one from the right side. Influence line of QM, again, it's 0.5 to 0, and then minus 0.5 to 0, and 0 beyond. Because when the load is running below, it doesn't affect the upper one. Influence line, when it's running above, it affects the lower one, and when it's running below, it doesn't affect the upper one. Influence line of MM, 1.5 PAV over L, which is 2.5 by 2.5 divided by 5, which is 6.25 divided by 5, which is 1.25 to 0 to 0, and at the 0 to 0 at the end of the intermediate hinges, and 0 beyond. So this is the influence line of the minimum influence line of the shear at M, influence line of minimum at M. What about K? K is just right of this, the second intermediate support. So this is point K. So what about the influence line of K, which is on the supporting beam below? Okay, when the load moves at the top, it gets affected by this one, but it doesn't get affected by the cantilever. So the cantilever portion of these two diagrams will be 0. So you only have values when the load is running on the supported beam, the one between the two hinges, and on the right one. So it's 0.75, 1.0 at B, influence line of QK, 1.2 at B, which is basically K, to minus 0.75 at the free end, 0 at the support point C, and minus 0.75 at the free end. And then from 0 to 0.75 at the intermediate hinge, plus to 0. So this is the influence line of QK. Influence line of MK. 0 when the load goes right of K, it's 0. When the load goes to left of K, it has a value. When the load is running on the cantilever, it doesn't have a value. So it's only bound by this part of the beam left of K, in addition to the upper one. Okay, so 1 point the moment is 1.5 at the tip of the cantilever, 1.5 by 1, or 1 by 1.5 to 0 to 0, and negative moment. So this is to 0 up to the end of this hinge, and minus 1.5 at the other hinge, and 0 to this cantilever, and this is 0 to this intermediate hinge. So this is the influence line of MN. So we're done with this example. We're going to cover another one which also has two intermediate hinges. So this one, beam has fixity, two intermediate hinges, and two roller supports. So for the shown beam, draw the influence line diagrams for the reactions. for QN, QM, QK, QN, MN, QN, MN, QM, QK, MK. In this one, I draw the influence line of the moment diagram. Okay, and we have the sections S, M, N, and K. So we also draw influence line of QS, MS. It's not written in the head of the problem, but it is there. So we have four sections, S, M, N, and K. S, M, N, and K. So we have S, M, N, and K. So we draw the influence lines of YA, YB, YC, and then MA. In addition, on the second page, we draw the influence line of QSMS, QM, MM, QK, MK. Okay. Influence line, now as we said, we divide the beam at the intermediate hinges into three beams. The top one is the supported one. We replaced the intermediate hinge by a hinge. So it became like a hinge support, roller support, and cantilever. Supported on the lower one, free end that carries the reaction from above, roller, and then the other intermediate hinge, we convert it to a hinge support. And the third one, which is the supporting one, it's a cantilever beam, fixed and free. So we have supported beam, and supported beam. So supported, and this is what is supporting the upper one, but it's supported on the lower one. And then the lowest one, which is a cantilever, is the supporting beam. Influence line of YA, which is reaction, vertical reaction at the fixity. How does it look like? It is 1 when the load is at the fixity, 1 when the load is at the tip of the cantilever, 0 at the intermediate roller support, -1 at the intermediate hinge, 0 at the at C or point C, and then by similarity triangles plus zero point 0.5. So this is the influence line of YA. 1 up to 1 constant plus 1 until the intermediate hinge goes to 0 at this middle support B, and then -1 at the intermediate, the other intermediate hinge, 0 to the other support, and then plus zero point 0.5 at the free end. Influence line of YB, 1 when the load is at B, 0 when the load at the intermediate hinge, 0 when the load is sitting on or moving on the cantilever. So 0 when the load is moving on the cantilever, 0 at the intermediate hinge, 1 at the support point B, 2 at the intermediate hinge, 0 at the roller support C, and then -1 at the free end. So this is the influence line of YB. Okay, YB, which is this point YB. 1 at YB. It's always 1 at the support point. Influence line of YC, 1 at YC, 0 to the intermediate hinge, and then 1.5 by similarity triangles to the tip of the cantilever, and 0 beyond. Influence line of YC is this one. 1.5 to 1 at the support, 0 at the intermediate hinge. Last one for reactions, influence line of MA. When the load is at the tip of the cantilever, it's 5-meter cantilever, so moment is -5 to 0. It should be minus, not plus. Sorry, this one is reversed. So it's -5 to 0, and then -5 to +5. Okay, and then to 0 to 2.5. So 0, -5, 0 at this intermediate support, -5 at the intermediate hinge, 0 at the support, and plus 2.5 at A. Just 1 second. So when the load is at the intermediate hinge, which is this second beam, the second one, the moment is MA is -5. Should be +5. Because it's drawn with the tail is above, so it's minus. So sorry, the signs for the moment have been reversed. So it's -5, below is -5, and this one is -2.5. Influence lines for S to QS and MS, which is somewhere, a point somewhere in the cantilever. This point S. So the cantilever is 5 meters. S is 3 meters from A and 2 meters from the cantilever. Influence line of QS. When the load moves left of S, there is no shear at S. When the load is left of S, there is no shear, and it is 1 up to the free end, and it is 0 at the support, -1 at the other at the intermediate hinge, 0 at the other support, and 0.5 at the table. Look at table. So draw a straight line, horizontal constant at 1. Straight line going through 0 at the support, a straight line going through 0 at the support. So this is the influence line of QS, and S is this point, which is at in the cantilever. Okay, so this is the influence line of QS, the upper one. Influence line of MS, when the load is at S 0 and left of S is 0. When the load is at the table of the cantilever, it's -2. So 0 at S, -2, sorry, to 0 at the support, to +2 at the intermediate hinge, to 0 at the support, to -1 at the tip of the cantilever. So this is influence line of MS. Influence line of QS is the upper one. Influence line of MS is the second one. Influence line of QM. Okay, it's 0 at the intermediate hinge, +1 at the support, to 0, left and right, to +1 at the intermediate hinge, to 0 at the other second support or support C, to +0.5. So this is influence line of QM, which is this one. Influence line of MM and MN. 0 when the load is at M and N, 2.5 when the load is at the intermediate hinge, 0 when the load is at the support, -1.25, +1.25 when the load is at the tip of the cantilever. So this is the influence line of MM and MN. Influence line of QK, which is this point, okay. It only has value when the load is on this top beam where the K point is. So it's +0.5 to -0.5 at K to 0 intermediate hinge, from +0.5 to 0 at the YC or at C to -0.5. So this is influence line of QK. Influence line of MK. 2 by 2 divided by 4, which is 1 positive, to 0 at the hinge, 0 at the support, to -1 at the cantilever. So this is the influence line of MK. Influence line of QK is this one, influence line of MK is this one. We're done with the 2 examples, and then the next one we're going to take more examples in the next lecture. Hope you guys enjoy the lecture, and we'll talk to you soon. Thank you. Bye.